Welcome back. So today's topic is membrane transport, and first of all everyone, happy Akshaya Tritiya. Now, without delay the time, let's get started. Membrane transport. Okay. Now, first of all, in membrane transport, we talk about the Fick's law. It is a valid for the simple diffusion across the membrane. Any uncharged possible non-polar molecule which have a delta G negative in positive in the case of hydropathy index cross the membrane without any assistance or help interacting with the lipid bilayer. It considered depend manner high to low preferably for Fick's law. Obviously बात है. Obviously high to low is always the delta G negative. Membrane crossing by number of molecule permeability into area C2 into C2 minus C1. Here is the formula dN upon dt is equal to P into A bracket में C2 minus C1 where P is equal to KD upon X. Permeability coefficient is equal to P where K is the partial coefficient, D is the diffusion coefficient and X the width of the membrane. K is equal to Cm upon C aqueous. D is the volume concentration into the temperature upon 6 pi eta square. Here n is the velocity of the membrane, R is the radius of the number, volume concentration is equal to V, T is equal to temperature. C1 minus 2 is the across the membrane, D is equal to KT upon 6 pi eta square, eta R. Simple diffusion is equal and concentration dependent. Now we talk about the how's the conditions following the diffusion. Temperature is directly proportional to diffusion. It's obviously thing because temperature when high temperature the things is more soluble or more movable condition, so it's directly proportional to diffusion dN upon dt. Number of lipid viscosity is inversely proportional to diffusion because thickness is prevent the movement. Molecular size is always inversely proportional to the diffusion. Width is always inversely proportional to diffusion. So we overall said time, distance traveling, distance, width, molecular size, velocity inversely, and temperature is directly favorable to diffusion. Okay, high molecule move across the lipid, high permeability, concentration if high, so C2 is greater than C1. Here is the two temperature, tryptophan charged or indole uncharged. Okay. Now we talk about the list which are more movable as compared to another one. Water 10 to the power minus 2, indole 10 to the power minus 4, urea glycerol 10 to the power minus 4, minus 5, glycerol, glucose 10 to the power minus 6, chloride 10 to the power minus 10, potassium 10 to the power minus 12, sodium ion 10 to the power minus 14. So they have a more permeability in membrane as compared to the ions. Tightly bound water due to the small size, so tough to permeable. Okay, water bound or released by amount of energy. That amount of energy is called hydration energy. Lattice energy is completely inversely proportional to the hydration energy. The bonding is known as lattice energy, breaking down is the hydration energy. Lattice energy high, so it prevent the molecule connect with the water, and if it's not connected with the water, so it quite not easily permeable. So in the non-polar surface, hydrophobic, so high lattice energy, so not like tightly bound with water, so water release energy give by membrane require low energy to separate with water and easily cross. It means they are the easily movable because they have a high lattice energy, and lattice energy is completely inversely to the hydrogen energy, so they are the bounded or compact form, so it easily diffuse because the size is small. But in the another molecule they have a hydration energy, it means they have a large in the size, they are the polar, so large size material is not easily permeable. Okay, so overall is that the core is that lattice energy favorable for the movement of the particle from inner membrane, and the hydrogen is completely reverse for that. Okay, atom radii directly inversely proportional to water bonding. If atom radii is high, so it prevent water binding and easily movable. Okay, now we talk about the why the sodium, potassium and calcium are not easily permeable. Atomic number increase, so their size is also increase, and they have a take a high hydration and now, so they have a high hydration energy, not easily permeable. If we talk about the differentiation between sodium, potassium and calcium, so if we talk water, so their atomic number 281, 28881, 2882, it means it is atomic number is 11, it is 19 and it is 20. So the calcium ion have a high atomic number, so they have a low water hydration energy. The water not tightly bound, so So water not easily tightly bound to compared to the sodium ion due to large size. That why potassium much more permeable to sodium ion, because sodium ion. So overall is that the atomic number of the sodium is small as compared to potassium. So they have a more impact, more water molecule tightly bounded. So it need more energy as compared to potassium. So is that's why potassium is more permeable at compared to the sodium, because sodium have a less atomic size and the less atomic number, so it have a high hydration energy as compared to potassium. The potassium is as compared to the sodium have a high lattice energy and low hydration energy. That why sodium is easily permeable as compared to the sodium. Okay. Carrier help to form enzyme substance complex. They change conformation after bind to solute. Channel is bind to solute but not change the conformation. Explanation: sodium ion does not pass through the potassium ion because sodium ion is small, tightly bound to the water, and that's what I talk in last page, and require high energy to break hydration energy. So in the potassium channel not high energy because its size high, so it require lower hydration energy. Potassium high not pass to the sodium ion because sodium is small size, so channel also small size. So potassium due to the large size not fit in the sodium ion channel. That's why though both are completely not fixed in another pocket. Sodium in with potassium channel because require high energy fit but not break hydration energy given by surrounding water. Potassium break in with sodium and because it need high energy high break but not fit, so high how it is break it. The diagnosis non-polar pass directly, so activation energy high, but polar pass through the transport, so transport act as enzyme and reduce its activation energy. Here is the structure, how the delta G is vary in case of the polar and the non-polar. Okay, so we talk about here transport, carry, channel, secondary active. Transport divided into the two substitute, carry and channel. Carrier is divided into the three substitutes: secondary active transport, passive transport, and the primitive active transport. Now we talk about the carrier. If it contain power, if it need power to power, it use ATP as an energy product energy. So it transport 10 to the power 0, 10 to the power 3. If not, ATP use as energy, not power. So there's that divided into 3: uniport, symport, and antiport. Now we talk about the transport. 10 to the power 2 to 10 to the power 4. Ion share 10 to the power 7 to 10 to the power 8. So mostly we talk about, so in case of the transport, power, transporter, channels. Okay, now we talk about the carriers. They are not need energy in the form of the ATP uniport. Along the concentrated energy given by the concentrated gradient, glucose transport across the cell. It means they move only one direction. Symport, they move they move in the same direction, but one is concentration dependent and one is against the concentration. One against the concentration, one along the concentration. Again, take energy by along both some direction. Sodium high to low, glucose low to high. So sodium high to low, so is that along the concentration, but here glucose always concentrate high inside the cell and low in the outside cell. When it enters the cell, so it's always move low to high. Antipode both opposite direction. One is along the concentration, both are along the concentration but opposite the direction. Okay, so transport, ion movement mostly done by the transport, then ATPs, then ions, because 10 power 2 to 10 power 4, 10 power 1, 10 7, 10 power 8. Okay, 3 type ATP powered one, P type, V type, ABC, all transfer molecule opposite direction against the concentration. If we talk about the ions, so it move ion pass ion per second 10 power 7 to 10 power 8 ions move per second. Powers की बात करते हैं तो which contain power, the calcium ion use ATPase, ion pump, ABC, cystic fibrosis, calcium channels, potassium and sodium ion channel, transport across the epithelial membrane. If we talk about the concentration, sodium ion concentration, inside 12, outside 144, so it move if outside inside is along the concentration. The potassium ion inside 139 and outside 12. If it moved inside, so outside it's concentration dependent. Calcium ion concentrate 10 to the power minus 7 inside, 10 to the power minus 2 outside. If move outside to inside, is concentration dependent. Glucose, it's always move inside to outside, so it is concentration dependent. Okay. Now we talk about the non-powered transport. Non-powered high to low for one energy released by concentration. Here T is the carrier because change in the conformation. ATP powered against the concentration low the high energy in the term of the ATP. T1 प्लस सबस्ट्रेंट आउटसाइड T1 डेफिनेटली हाई है बाहर आउटर कंसंट्रेशन में, तो ये मूव करेगा डायरेक्टली स्पॉन्टेनियस. फिर ये इनसाइड आएगा, यहाँ पे ये इसका कन्वर्ट होगा T2 प्लस S इन, लो एफिनिटी होगी यहाँ पे S इन के साथ, तो S इन के साथ एस इनको लेके T2 वापस चला जाएगा बाहर कंसनट्रेशन, मतलब जो उसको डिलीवर करना था डिलीवर किया, और जैसे डिलीवर किया उसकी एफिनिटी जो थी वो इनसाइड कम हो जाएगी और वो उस चीज़ की एफिनिटी को ब्रेक डाउन करके वो बाहर सरफेस पे चला जाएगा. Now we talk about the glucose transport. It is an example of the unipotent that transport glucose along the concentration gradient. Glut transport are made of the 12 trans membrane. It means one in, one out, one add, and it is an example of the type 3. Active site of the glucose transport, it's conserved 7 residue SLB TNFI. It's a short form. When we talk about the serine, leucine, valine, threonine, aspartate, phenolphthalein, and isoleucine. Phenylalanine, ठीक है. फॉर्म हाइड्रोजन में विद द ग्लूकोज, ब्लड टू सेल और लीवर टू ब्लड, डन बाय glut transport. Here the leucine, valine, isoleucine and phenylalanine interact with the core of the membrane. Basal glucose uptake glucose 1 and the glut3 blood. If the glucose concentration move blood to liver, so its affinity low, मतलब affinity low. Km is the concentration of the substrate which are need to fulfill the half of the active site of the enzyme. Liver to blood, if Km is high. Glut5 responsive muscles are cardiac, it is the fructose transport. Glut11 heart, skeleton muscles, kidney, its Km is 0.16, highly affinity. Glut4 is basically regulated by insulin. D glucose 1.5 is the top. Now we talk about the list. Glut1 ubiquitinate, its Kt is 3. Glut2 is its Kt is 17. It help in the transport between liver, pancreas, isolate. Glut3 is 1.4, help in the brain and testes. Glut4 is increased by the insulin. It Kt is 5, muscles, fat, heart. Its Glut5 is fructose transport. Its Kt is 6, intestinal, and least is Glut11. Its Kt is 0.16, so it's have a highest affinity. Now Glut10 is also Glut10 is 0.3, Glut9 is 0.6. They are able to fulfill the requirement of the body's organ which demand glucose. Okay, insulin bind to the receptor here. Glut4 active, attached to the plasma membrane, start uptake glucose from blood to cell, maintain glucose level in the blood. Insulin release. Glut4 detached to the plasma membrane, endocytosis. Glut4 inside cell, blood glucose to the cell, prevent. If oral is that, if we take the sugar, the blood concentration of the sugar is high, so insulin bind to the receptor, activate Glut4. Glut4 come to the plasma membrane and start uptake glucose from the blood to the cell. When the glucose level can maintain in the blood, insulin release from the receptor. Now Glut4 detached. The connection between to transport glucose from blood to the cell is also detached. The endocytose, Glut4 inside the cell, glucose to cell, prevent. Okay, it is the structure how the Glut4 work it. Okay. If insulin not work, mutant is called diabetes insipidus, and it is type 1 diabetes. Okay, now we talk about the water permeability of the epithelial cell and renal collect duct in the kidney due to the aquaporous 2 in apical plasma membrane, lumen, non-cytovasodilation, antidiuretic hormone. If antidiuretic hormone is mutant and it is synthesized by hypothalamus and stored in the posterior pituitary, synthesized hypothalamus, water permeability greatly. If antidiuretic hormone is a mutant, so more urea, more concentration, more diluted urea, and it's called type 2 diabetes, is known as the type 1 is diabetes mellitus or type 2 is the diabetes insipidus. So if the diabetes related to the insulin is known as type 1 and diabetes mellitus, or if it related to the aquaporin 2, so diabetes insipidus. Now we talk about the symporter. Glucose and sodium are input together in the enterocytes by the co-transporter. 2 sodium ion and 1 glucose in the transport in the small intestine and the kidney by transporter known as the sodium glucose transporter. Now sodium ion transport out to in along the concentration, glucose out to in against the concentration. Both move in the same direction. The two type of the SGLT1 and SGLT2. SGLT1 found in the kidney tubule and intestine. SGLT2 found in only in the kidney tubule that reabsorb glucose into blood from the urea. So SGLT2, so blood glucose high concentration. If inhibit SGLT2 selectively, so glucose not absorbed from the urea, so blood glucose sodium and increase. So SGLT sensitive inhibit is called diabetes second or diabetes insipidus. Now, if if the person is survived of the diabetic, so SGLT2 found in kidney, tubule, and intestine. If we mutant SGLT2, so it not absorb the glucose concentration in the from blood. So the urine contain high glucose concentration. So glucose not absorbed from the urea, so blood glucose not increase. So blood glucose not increase because it's not able to absorb. So it's particular person contain a particular person urine contain a high sugar concentration is eluted excrete out from their body, and it is such maybe a future treatment for the diabetic persons, maybe. 2 sodium ion, 1 glucose, 2 sodium and amino acid, neurotransmitter, co-transporter. Carrier use Michael-Melt's equation V naught is equal to Vmax and 2s upon Kms. If we talk about the antipoda chloride and bicarbonate and an exchanger. Now here's the structure, how the things is work. In lungs we contain the water, we contain the oxygen and move into the cell tissue. Here is the contain high concentration of carbon dioxide and water react in the presence of carbonic anhydride. Now here come into the bicarbonate plus HN plus Cl. Now Cl is elute from the tissue. Now here Cl come into the lungs, react with the HCl and नो इसको मैं बाद में डिस्कशन करूँगी, लेटर ऑन इसको मतलब पर्टिकुलर मैं एंटीपोटर को डीप डिस्कशन करूँगी. नाउ वी टॉक अबाउट द maybe it's take another round because if I done it fast it is not well. So we meet you tomorrow. I think or I realized today's topic is not covered by me, so let's meet tomorrow. Bye bye with improvement.